Hey, hey, hey. What's
Hello.
going on,
Hello.
everyone? How are we doing? Welcome back to the
Hello.
Routing Loop. This is part of our Chalk Talk series. So, as you folks would have known, we had reInvent last year, and I think, and I think everyone agrees with me, one of the best things you can do at reInvent is go to the Chalk Talks because they're not recorded, sadly, but they're not recorded, which means we talk about whatever we want. Just kidding. But Chalk Talks are basically how many people do we have in Chalk Talks? About 50 people or so,
About
give
50,
or take?
60.
Yeah.
Yeah. Okay. So they're very, very small rooms where you get to ask questions and talk to AWS experts about things that are important to you. And generally, there's a topic. Now, because folks can't all fit in the one room at reInvent, a lot of people miss out. So we do this Chalk Talk series on the routing loop. And today we are doing solving private IPv4 exhaustion using AWS Cloud WAN and Amazon VPC Lattice. And so we have Alex Hudez, who you all know, one of our rock stars in networking here at AWS. And we have Mehdi, another networking essay here at AWS. And so the format here is any questions, post them in the chat. We'll talk about that. But I think let's get started. Tell us a little bit about IPv4 exhaustion and maybe why we wouldn't use V6 as well. I'm super curious.
No. What do you mean, man? What do you mean? We would use IPv6. Everyone should use IPv6. Let's just
What do you do if
clarify
you
that.
can't use V6? Let's rephrase that. If you
Exactly,
can't.
exactly. If you can't, and if you're like, oh man, I would love to use V6, but there's first, for various reasons, we cannot use V6. This is what I think you should do, what we're going to be talking about today. But I would like to be stated, recorded on tape and on YouTube and on Twitch that you should absolutely do IPv6. Let's stop doing
Excellent.
that.
What are some reasons why you wouldn't use V6 though? The only example I could think of was you've got a super old manufacturing device and it's sitting somewhere and you can't change the IP and it's been running since 1975 and it only runs V4. Are there any other reasons?
Correct. No. those are the reasons, but also the fact that we as a humanity overall have become really, really good at doing that. We're very comfortable with that. So we're like, oh, what would I need V6 if I can just do NAT? Oh, what we're going to be talking about today is actually glorified NAT, if we could talk about it like that. But yeah, I think it's just the fact that we're kind of accustomed to the things that are bad, and we're like, nah, why would we change it?
Maybe V6 addresses are just too long to remember. I'm trying to trigger Alex here.
Let's not make this a V6 conversation. But yes, maybe they're too long to remember. People are very, I would say, are wondering usually how do they secure these addresses given that there's no NAT translation. And this is a cue for myself to also state on tape and recorded that NAT is not a security mechanism. So do not use NAT as your security mechanism. But yeah, I mean,
I think NAT
we're
is a
creatures of habit.
comfort mechanism. And Karim, I want to call out his comment here, and I can't click on comments today for some reason, but he's saying, I think there is also the comfort factor with V4. V6 is scary. And I think that comes into play with NAT. NAT, there we go. NAT is a comfort mechanism as well. And security and comfort always kind of feel the same, right? But obviously, security is a lot harder of a boundary versus comfort, which is, hey, I really like the fact that I have these private addresses that no one can reach. Well, maybe if there's a hole open somewhere, they can reach those, right? So, but how are we going to approach this today? So we're running out of V4 addresses. What are the mechanisms that we can use outside of V6? Let's just pretend in a world where you're like, hey, we're going to stick with V4 for now. What can we do about that? And I mean, we've all spoken to some of our largest enterprise customers that are running out of things like RFC 1918 address spaces. You know, how do those folks deal with that? You know, it's like, hey, there's no more spaces. We can't use V4 anymore. Like, what are some of the mechanisms that we can do there?
Hint for everyone before you start, Mehdi, it's still not. So don't expect anything new. It's still network address translation.
Yeah.
Also, very excited to see a bunch of our friends here, Dominic and Karim. Thank you folks for joining us every week here on the routing loop. So really excited to see you. Over to you, Mehdi.
Thank you, Alex. I think if we could just bring up the screen share.
Yeah,
So
for sure.
I think from my experience, and I completely agree with you, Alex, should use IPv6 100%. Just when I speak to a lot of our customers, I see is what's blocking them is the perceived effort to go to IPv6, right? And they at the same time, they still want to grow, they still want to deploy new stuff, and they're running out of IPv4. So that's why we're here talking today, right? So the message is 100% go IPv6. Yeah. In the meantime, while you're doing this, there you go. You could still grow your footprint if you want on AWS with using IPv4. That's the problem we're trying to solve today.
Yeah.
So.
Perfect.
So we got a few slides today, and the first thing I want to say is the problem statement. So what is the problem we're going to say, which we just talked about a little bit now. Then we go through how it's solved today, and what are the challenges with the current way of solving it, and then we proposing a different approach, maybe a more cost efficient approach, and then we got the solution details, and then we close after that. But obviously, we'll be taking questions throughout. So the issue, as it's been mentioned, is running out of private IPv4. So RFC 1918, this is the 10/8, the 172.16 and so on. So, this seemed, and what part of the issue is because we see at the beginning, it looks like we have loads of, it's a huge space, right? So we're never going to run out. I think it's /8. I think it's something like 16 million IP addresses. So we start allocating these IP addresses generously, right? So, and then especially with large enterprise, they have multiple sites, and each sites get a big chunk of that. And then we end up with that issue where private IPv4 becomes scarce. And when you come to deploy your workload in AWS, you don't have enough, right? So I'm guessing a lot of you would have had that kind of conversation, right? So if you want to deploy something, you go, can I please have a /24? And then the answer you get is, why? Can you explain?
Exactly.
These things are scarce. I want to deploy it because X, Y, Z. And there you go. You only get a /26, and you have to live with it. And obviously that's not enough for you, but that's all you're going to get. Can I use IPv6? That's the right question to ask. And often it's yes, we're working on it, but not just quite yet, right?
Yeah.
So
one thing here, I see a comment from Prof. Corey here. This says that very interesting problem. I hear a lot, actually, in conjunction with IPv6 too, and with why would you not adopt it? I hear a lot of smaller scale customers who are saying, well, I'm not running into private IPv4 exhaustion issues, right? I'm not there yet. I still have, how can you exhaust 4 million IP addresses that are the private IP space in IPv4, right? I'm nowhere near that. Private IPv4 exhaustion is, for the solution that we're going to be talking about today, is not the only reason why you would implement this. Private IPv4 exhaustion has a side or a complementary issue here, which is overlapping IP space due to mergers and acquisitions, due to developers who are going in and saying, I'm just going to create my own VPC and not care about what IP addresses the network engineering team is giving me. So these are they create this ecosystem of problems, of challenges, due to the fact that IPv4 addresses have this private space that everyone can reuse in their environment, and that is also limited, right? So I think it's worth not tuning out of this session just because you're saying, oh, I don't have private IPv4 exhaustion, I'm going home, closing the Twitch or YouTube stream. You may still have a need for this solution we're going to be talking about today.
Yeah, Thanks for pointing this out.
I was just thinking too, maybe we need a feature for VPC that's VPC IPv6 by default. I think one of the challenges that we have with customers is myself as a user of AWS, I do the same thing and I go for the path of least resistance. And so when I spin up a VPC, I say, oh, just give me a default VPC, or I'll spin it up in this VPC. Give me a 10.1, spin up this stuff. Away we go. Oh, this test thing that I just built kind of work, and I'm going to turn this into production now. And then away you go.
Yeah.
Right?
Also, don't get me started. In AWS, in every single region, you get the default VPC that has the same IP address everywhere, so it's overlapping by default.
Well, maybe we should
yes.
talk about that too. You know, if you've got many VPCs, customers will say, oh, I'm just going to do 10.1 everywhere. How do you approach that?
Yeah, you
don't do that.
Surprised how often we see that.
Don't do that.
Well, I think the issue is folks in the know not to do that, but a lot of folks get brought in, and you know, a lot of folks on the routing loop here are networking folks, and they know the best practices on how to do this. I mean, we have new folks here too, so welcome as well. But I think they get called into situations where the company says, I can't spin up another application. And they say, okay, well, why not? Oh, someone told me I couldn't have another VPC. Oh, well, why not? Oh, because it can't talk to my other applications. Why not? Everything's addressed in a 10.1.
Yeah.
Right? As you chip away at the layers, you find out someone who was just holding the fort together said, we need more space. Things aren't working. Let's just deploy. And then they'll fix it later. Right? They say, oh, now let's hire a networking person to fix the mess. And so I think in a lot of cases, you get brought into these scenarios, unfortunately.
Yeah. I mean, we can definitely touch on that when we talk about Lattice a little bit later. Because that will address overlapping IP addresses.
Okay, we only have 60 minutes and the time does fly, so let's keep rolling.
Yes. All right. So how is this problem currently solved, right? So basically, how do we see a lot of customers solving this shortage of IPv4 addresses, right? So it looks something like this, right? So you get a subnet, which is non-routable. It only routes within the VPC, not outside, meaning that you can take that subnet and reuse it in multiple VPCs and deploy your workload. This is like particularly used when it comes to like things like containers that are quite greedy when it comes to IP addresses, right? And then you have another subnet, which this time is routable, right? But you can use a smaller subnet, right? And in the VPC, you go and deploy your NAT gateway for egress, but you also need ingress to reach your workload inside the VPC, because remember, those IP addresses are not routable. And that's where you deploy things either like a load balancer or private link within that routable subnet, right? So, and we see that this pattern quite a lot. And this has obviously two advantages. One is you can scale because you can deploy that large non-routable subnet and deploy your workload, so you have no issue there. But also you minimize the consumption of your routable subnet, which is the one at the bottom, because you don't need that many IP addresses there, right? So far so good, but it's got a couple of challenges, right? So the problem is you end up replicating that in multiple VPC, if not all of your VPC. So what that leads to is you end up fragmenting your routable space, right? So meaning using it not very efficiently, right? But the other problem is you end up deploying like NAT gateways and private link across all your VPCs, which increase your costs, right? And then the last thing is that it reduces visibility, because this workload on top are hidden behind the NAT gateway. So if you have a firewall or something further down your path, you won't be able to see the exact workload. You will just see your NAT IP address. Right. So what can we do about it? Right. So what's an alternative approach? So the idea is to
Actually, before we go that path, there's a really good question. If you want to go to the previous slide, from Karim here, who says, "Are you still able to correlate end-to-end flows and VPC flow logs? I still know who is talking to who." With a lot of work, and actually, the fact that the NAT gateway abstracts essentially multiple workloads behind it. There's technically no way, like you will know which workload sends traffic to the NAT gateway, and then NAT gateway sends traffic further. But in your routed network, you will see essentially NAT gateways talking to ALBs or private link endpoints. Like those are going to be the IP addresses that you're going to be seeing in your like routed network over transit gateway / cloud WAN. So not great from a security perspective, I might add.
Yep. Okay, so
would you be tempted to configure some form of static one-to-one NAT instead of using? I mean, NAT gateway is really a PAT; it's a one-to-many.
If you do static NAT, then you should do IPv6 because you're not gaining anything, right? You're like, if from private or non-routable IPs, you NAT to routable IPs in a one-to-one fashion.
Yeah, but you're not saving any IPs either.
Yeah, exactly.
If you're running out of IPs.
I think it would be in a case where you would have overlapping IPs and you would have a division of ownership where someone says, don't touch my application, but it needs to talk to this other thing over here, and it needs two-way communication, two-way initiated communication, not just patting. And so then the networking folks say, well, my boundary of ownership is the VPC routing. I can send packets to another instance, and I can then do static one-to-one NAT to an address range that's unique and allow two-way communication. And I could see that happen. I agree, V6 all the way, but if we have customers that come in and say, I can't touch my application, I can't change my IPs, how would I
I think you've just described how VPC Lattice resources work.
Yeah.
We should probably whiteboard that when we get to the Lattice.
Yeah, I'm looking forward to it. Let's keep going. You can pay me later for the setup.
All right. So alternative, there's still NAT in there, but there is less of it, right? That's the idea. So the idea is to assign a range that is routable within AWS only, right? It's not routable outside of AWS, meaning you need to NAT only if you leave AWS, right? Within AWS, then you can route. There's no need for NAT gateways inside the VPCs or private link within those VPCs, right? So, and there's also probably a good point to, if you want to, we're going to talk about it later as well, apply inspection there. So if we zoom out a little bit again, this can be applied cross region. So if you have enough space that you could use for this purpose, you can have just one single domain across all your AWS regions, or you can have the same space between regions, and then you'll have to NAT between regions as well, depending how constricted you are in terms of IP address. Ideally, you'll have like one big domain that goes across your regions, right? You will have to NAT at the regional level, and this range can also be used elsewhere, not just in AWS. It can be used on in your data centers, as long as it's used behind NAT devices and not advertised within your, if you want, like WAN, if you want, or global corporate network. Kind of things like this big box here should not know about this 100.64 subnet.
I would add one quick thing here, that AWS routable IP domain doesn't necessarily need to be 100.64. Could be a prefix that you've decided out of the 10 space or 172.16 space that is going to be sort of cloud routable. So just for everyone to know, because I've gotten this question a lot, as in, does this architecture work if I do 100 dot, I don't know, sorry, not 100, 10 dot, I don't know, 10.128.0.0/9 or something like that. And I'm like, yes, absolutely. Works with any CIDR that you prefer and you reserve to use as just strictly AWS routable.
Yeah, I use it as an example because in most customers I work with, they don't tend to use that on their corporate network, right? So it's not used generally, right? Some do use it, but if it's not used, it's there for you to use. So you could either like advertise it, but if you're using it elsewhere, do not advertise it.
I think, and there's a bit of a conversation in the comments actually about the CGNet space. I think I'm seeing that more and more. I don't know what you folks are seeing, but more and more customers are kind of cottoning on to, hey,
Yep.
CGNet space is untouched. Maybe we'll use that. It's an extra 4 million IPs. That buys us some time.
Yes, exactly. You know what the thing is? Extra 4 million IPs that buy us some time till we will need the next extra 4 million IPs that we won't have where to get.
Sadly, that's what we see.
Exactly. Yep. So summarize the principle we're talking about here. So if you're going from AWS to AWS, there is no NAT, there is no private link, right? If you're going from AWS to your on-premise network, then you NAT. From on-premise to AWS, you go through private link. And if you do within your company routable IP domain, then again, there is no NAT or private link there. So how does it look like?
Can we just go back to the other architecture? Because we have two questions here, and maybe Alex, you want to click on them. The first one was, can Cloud WAN be configured to only share the routed space among regions and not the overlap?
Yes. Here. Can Cloud WAN be configured to only share the routed space among regions and not the overlapping one? I believe that the new roadmap feature might work for this. You don't actually need that to begin with. The reason for it is because Cloud WAN works exactly like a TGW when you enable propagation for an attachment, or for many attachments in this case. They're all by default propagated into the segment. Cloud WAN will see the first VPC that has the overlapping IP space and be like, okay, I'm propagating it from this VPC. And then every subsequent VPCs that come with the overlapping IP space, Cloud WAN will not propagate that CIDR. That's part number one. Part number two, you can always put a static black hole route in Cloud WAN to say this space that should be overlapping, instead of advertising it to on-prem or advertising it over VPNs and whatnot, I'm just going to do a black hole route on it. The third one is here, as we're going to get to the Cloud WAN, the Cloud WAN deployment, these are usually separate segments in Cloud WAN. So the VPCs are attached to a segment, and then routing is done through a NAT segment, which is represented by a network function group most commonly. So it's pretty easy to do that.
Yeah. The other thing I'd like to add to this is just keep in mind that the point of this is not to have overlapping CIDRs within your AWS environment. So you don't have to NAT or filter. You can just route and make it easy. That's the whole point of this architecture.
Yep.
A couple other comments here. Well, first, I just want to call out Ken's comment about it was a lifesaver around carrier. I think you're referring to the carrier gateway NAT. Carrier grade NAT. For that one, I think the comment still stands in that as a lifesaver, but think about V6 as opposed to lifesaver until it runs out. Okay, let's move on to Tech First's comment.
Can regional NAT gateway work in this scenario? Regional NAT gateway for now does not support centralized architectures. Centralized egress, centralized NAT kind of architectures neither on TGW nor on Cloud WAN. We can talk about roadmap in this show, but keep an eye on the space. We hear you. We understand the use case. We'll get back to you.
Okay, so let's look at some details, right? So how does it look like? So you have your AWS environment, and you've got your AWS routable IP space. So in this case, let's say we're using 100.64/10. That would give you a lot of room, right? So for instance, like more than 4,000 VPCs with /22 CIDRs. So that's quite significant. So in this case, you go and deploy your VPCs, and you notice something. There is no NAT gateways in this VPC, and there is no private link in this VPC, right? So it's normal VPCs that can route within each other. So no need to NAT. So so we saving on your routable IP space, right? But we also saving on cost in terms of NAT gateway and traffic processing of those NAT gateways, right? And then you have your routable space. So in that routable space, we still need to take some of that space to use on AWS. So that's where your corporate network lives. But we also need to deploy NAT gateways. And these NAT gateways will live on that space, right? The 10/8 space, right? Not the 100, right? And it's centralized. So instead of having multiple NAT gateways, you're going to have centralized NAT gateways, and then you can route traffic to it. And then for ingress, we do something very similar. Sorry, you want to say something?
Yeah, just one thing here. Back to the comment that was made earlier around the visibility through the NAT gateway. If the scope of losing visibility in the previous scenario was just a VPC and the workloads deployed in a VPC, the scope of losing visibility in this scenario is literally everything in that region, because you're aggregating everything behind that single NAT gateway. So keep that in mind. Do
Yeah.
IPv6.
Sorry. Having said that, you still get to see the true IPs within AWS, right? So if you have some east-west inspection within your AWS environment, or even you can filter traffic before it hits the NAT gateway, you can see the detail of where it's coming from. But yeah, after the NAT gateway, then your entire AWS environment is hidden behind that. So for ingress, I said something similar. So you have centralized, you deploy your endpoints in there. Why are we doing this? Because you're going to save IP space. So instead of deploying this routable subnet in every VPC, you centralize them and you deploy your endpoints, your ingress endpoints in there, right? And that will give you access to your application. So now, the thing is, as you can see, you're going to have one endpoint per application, all right? So is there like a better, more efficient way of doing it? And that's where VPC Lattice comes into play and makes things much better. And I give it, so I'll hand over to you, Alex, if you want to talk about that.
Yep. So just to do a bit of a comparison with the previous architecture, in that ingress VPC, we showed how you could have an endpoint for every single application that you want to expose from your workloads that live in AWS to your clients that may live on-prem. Now, for those of you here who are familiar with VPC Lattice, this will sound totally familiar, but for those of you who are not, VPC Lattice comes with this construct, which is called a service network. That's what you see here on the diagram as that square that aggregates the yellow lines. This service network is just a logical construct that helps you aggregate things. We're going to talk about what things are in a second. Aggregate them together and provide them with common access policies. Now, back to the things. Here you see that you have VPC Lattice services. These are the first type of constructs that Lattice supports for you to expose into the service network. A service is a layer 7 construct. So think of it as a load balancer, an application load balancer with listeners and targets, very similar to a Lattice service. In addition to what an application load balancer offers, a Lattice service also has auth policies that you could use to further granularly control what can access that service. So in our scenario here, in our architecture, you would essentially define VPC Lattice services or resources, which are the second thing that you could associate with the service network. You would define your services and resources. You would associate them with the service network, and then you would have a consolidated access into your service network.
So I've got a slide on Lattice. If I can skip to it maybe and help with this conversation. Where is it gone?
I think that was just the primer for everyone here who's who's
Okay, there we
not
go.
necessarily super familiar with
Yeah.
with
We do
Lattice.
have
Oh,
a question
perfect.
from Karim. Does it have to be Lattice on the ingress side? Can it all be layer 3?
Can't it all be layer 3? Well, Lattice is an ingress that is layer 3, as in it has IP addresses on the service network endpoint, and you get layer 3 routing. Let's do this actually, because I think we're in for a good whiteboarding moment. Let me do this, and let me add this, and you folks should be able to see my screen, right? So
We can.
awesome. Awesome. So we have this AWS environment, right? We're saying that here's where we're deploying our VPCs, right? So let's just take VPC with 100.64 something, right? /16. And then we're saying, okay, for egress, you're going to be connecting this VPC to TGW/Cloud WAN. And then you're going to have a centralized egress VPC. Actually, this one should live in the routed space. That has a NAT gateway. Now, the egress here, something with 10 dot something. Now, routing, you are saying that this is kind of a layer 3 egress. So this NAT gateway does NAT and then sends it over on its merry path to the corporate network, right? This was the egress piece. For ingress, we talked already about that ingress part where you could have a fully layer 3 ingress. You could put load balancers in here. You could have this load balancer completely target another load balancer that lives in here, right? Let me do this a bit nicer here. And everything is the layer 3 ingress, right? Because this is a layer 3. You get IP type target here. This comes with certain limitations, to put it that way. This load balancer here needs to be a network load balancer, because otherwise application load balancers have dynamically scaled their IP addresses. So you would have to manage how you define those IP targets for IP addresses. The other part is for every single workload, you would need a load balancer here, right? Which means a lot of load balancers. Also, it means 2 load balancers for every single workload. Why would you use 2? Not super cost optimized and architecture optimized. So the evolution of this architecture was, okay, can we make use of private link? Like this sounds pretty good. Why can't I just put private link endpoints in here, right? So VPCE, that takes me, I don't even need to have layer 3 connectivity. I don't need to define IP type target groups. I don't need to do any of that, right? I just need to define a bunch of VPC endpoints in here. They are natively integrated with the load balancer here that needs to be an NLB. But if you have an NLB as a load balancer, you could also target natively an ALB here if your workload requires ALBs. So it's pretty straightforward things that customers already use today, right? This is also, it's kind of a layer 3 ingress, right? Because these VPC endpoints have IP addresses. This is, let's call it centralized ingress, right? These have IP addresses from 10 dot something, right? So they're routed from the internal network. Everyone gets access to them. So it is a layer 3 ingress of sorts, right? What we're seeing with Lattice is, how can we further optimize this? How can we just not do all the VPC endpoints here and get to a place where this is essentially a more streamlined ingress without us having to define all these load balancers. So here's where the Lattice idea comes into play, where you have the service network. You have this defined as a VPC Lattice service that is in itself a load balancer with a bunch of other features. And you can associate it with the service network. And then this service network for ingress has a service network endpoint, which acts as a sort of a consolidated endpoint, a consolidated VPC endpoint, but for all things that are in the service network. So think here that in the service network, you could have many VPC Lattice services, and you don't need to create a service network endpoint for every one of them. You can access all those services through the service network endpoint. Does this kind of make sense?
I mean, it makes sense to me, but
Karim, let us know if it does.
yeah, Karim, let us know in the chat if this answered your question. Okay, let's keep rolling.
Awesome. Let me remove my
All right.
my slide here, and let's get back to our architecture. Okay, so let's look at the traffic flows, right? For egress, so traffic initiated from AWS, we have the workload VPC going through Cloud WAN, going through the centralized NAT gateway, and going all the way to on-prem through DX connectivity or VPN. Return traffic is the same, right? Keeps traffic symmetrical, and then traffic originated from on-prem goes nicely through Cloud WAN to the service network endpoint, through the service network to the VPC Lattice service, and return traffic is symmetrical. So you have an ingress, you have an egress. The bigger advantage of this ingress too is that you can configure auth policies there on your service network. And auth policies do not mean that you have to have your traffic signed with SigV4, or do not only mean that you have to have your traffic signed with SigV4. In this case, for workloads on-prem, you would probably use SigV4A and IAM roles anywhere. But if you're not doing that, if you're not signing your request using SigV4, you can still configure auth policies based on source account, source VPC, source CIDR, source IP address. So you still have knobs to go and granularly control what from on-prem can access what service or what resource in the service network. The other super important thing here is that you get full visibility into what is talking to what. You get exactly the IP address of the client on premises, talking to the exact Lattice service in there in the Lattice service network access logs. So you get much more visibility than you get on the NAT gateway there, and just by looking at flow logs, which don't necessarily tell you that much around which actual workload is accessing which service on-prem, right? So for this ingress path, you get full visibility.
You got some details on the workflows. You want to go through them, or?
Yep. I think here's for those of you who are interested in terms of like how route tables are going to be looking like and how the segments are going to be looking like. We mentioned previously that you would probably have two separate segments, a workload segment and a NAT segment. And from a centralized egress perspective, you would be configuring routes to push all that traffic egress through the NAT VPC. And I think that's more than enough. We can go to the next one.
So the next one is just a summary of Lattice, which you did already, I think.
I did. Let us know, folks, in the chat. By the way, you folks are pretty quiet today. This is supposed to be a chalk talk. You should ask us a lot of questions. This is.
I think that's a side effect of such detailed slides. You know, it takes a while for folks to kind of take this stuff in, and it's like, okay, all the answers are in this diagram.
Yeah. It is also a 300 level session though, so you kind of need to know your routes and route tables and
Yeah.
how these work for sure.
You want to say a thing or two about VPC association versus endpoints?
Oh, for sure, for sure. So tech first. Before going that, I'll just address tech first comment. Too much was in the last slide. I would highly recommend taking a screenshot of the slide and then going in and saying, okay, what is this slide showing me here? By the way, all our sessions
let's go back
are
to that
recorded.
slide. Let's go back to
Yeah.
that slide. Are these slides available anywhere online? I think that's probably the biggest question folks have.
Yes.
Yes, they are on AWS events page. So folks can go there, download the PDF. You folks will have the recordings. All the routing loop sessions are recorded and you can find them on our routing loop page. So I'll put, or Matt, do you want to put the routing loop link in the chat?
I'll throw it in.
So you can go there, previous sessions, you can watch the recordings and go through these diagrams and be like, what is this diagram saying here?
So I actually did find your slides. I'm posting that in the chat here.
Awesome.
It was actually a lot easier than I thought it would be.
Nice. Perfect. Perfect. Now about Lattice. Raise your hands in the chat if you know what Lattice is and what Lattice does, and you know what this slide is saying. If you don't raise your hand in the chat, also let us know if you want a session where we go back to the roots and we talk about what Lattice is and what it does and why we've created it and what it supports, and we can definitely schedule something. As a 10,000 foot overview, in Lattice, you can expose two kinds of things, services and resources. Services are layer 7, resources are layer 4. So just think of it as TCP NAT. And from access perspective, you can access these services and resources either using a VPC association or a service network endpoint. The VPC association is very similar to an S3 gateway endpoint. You folks are probably very familiar with that. No ENIs in your VPC, just routes and route tables. The service network endpoint is like an interface endpoint. So it consumes IP addresses from your VPC CIDR, and it doesn't require routes. It can also be accessed from outside of the VPC. Hence, it can be accessed from on-prem, from other regions, through VPN connections, and so on.
Yeah. I think there's a clarification question. Yeah, there you go.
Okay, on auth policies here, are you referring to using the source IP in the auth policies if we're not using SIG4? Exactly. I'm gonna while Mehdi's going ahead with the next slide, I'll search the link for the documentation where we talk about all the condition keys that you can put in the policies. And for unauthenticated traffic, so no SIG4, no IAM principal ID, you can do a lot of things still. So you can match on a lot of other condition keys. Source VPC, source account, source CIDR, a bunch of other things. I'll put them in there.
We also have a question on DNS with VPC Lattice from Tech First.
Oh, yes. I would like to know more about how DNS resolution works in Lattice. I will find a blog. We have a blog that talks about how DNS works and how you would use Lattice DNS. Just as a super quick sneak peek, for resources, Lattice manages DNS altogether. Resources support what we call custom DNS. So when you define a resource, you can say this resource is called alexsresource.example.com. And all clients in all associated VPCs to that service network where you're exposing the resource will automatically get the custom domain name mapped. So they will be able to resolve automatically Alex's resource. I'll post that too in the chat for sure.
I already posted in the chat, but I think we should still do a session on DNS and VPC Lattice, though. I think that would be really useful for folks.
I think so too. I wish we had like 5 sessions a week, honestly.
We would, if we had 5 slots a week, I'm pretty sure we could fill it with good content. So
For sure. Yep. There's also one more question here. For ingress, just want to confirm that for every resource service that needs to be exposed to on-prem, it has to be defined explicitly. Yes, exactly. It's a very explicit intent-based configuration. Same as you would do if you would put a centralized private link endpoint, or if you would put a centralized load balancer that would target the other load balancer in the workload VPC. It's a very intentional deployment of a load balancer. And that stems from the fact that you don't have globally routable IP addresses. Hence, if you don't want to explicitly define every single thing that can be accessed from on-prem, you should use IPv6.
Yeah.
Cool stuff. Mehdi, do you want to go through this while I search for the link to our auth policies?
So in terms of the inbound routing, so let's start again. So you have your workloads, either HTTP or non-HTTP on top, like an RDS database, for instance, and you want to get to them. So how would you do that? So you need to have what we're calling an inbound segment, which is again another segment on Cloud WAN. So the same like where we had the NAT segment for egress, we have an inbound segment for ingress, which allow us to share the routes the way we want them. Then you deploy your Lattice, as we discussed, with your ingress endpoint in the centralized inbound VPC, and then you associate your services, your resources to this service network, right? And this association, right, will make them available through that endpoint, right? So they will each have a DNS name. We've been talking about DNS that you can access them through. So both resources and services, right? Then you share the routes between your inbound segment and what we're calling your hybrid, where your direct connect is attached to. So they learn each other's routes. So we can route between, in this example, the 10.1/20 of your inbound VPC and your on-prem routes. So because we're using the 10 domain, the 10 range, then we can route between them. We can advertise we can advertise the route of the two segments in each other, basically. So traffic is going to come in, get to the endpoint, and either go to your service or go to your resource, whichever the destination is, and then return traffic will flow through Lattice back to your inbound. It will hit that route on the bottom right, which says on-prem, and that will send it to your on-premises client.
Cool stuff. Oh, we also have slide on DNS resolution. I actually forgot about this completely. Yes, we talk about DNS resolution here too.
Yeah, so I think this slide is more about how would your on-prem know about those DNS names, right? That we define. So you might be familiar with or not, or with something called Route 53 inbound resolver endpoints, which allows you to access your Route 53 from on-prem, right? So that will give you access to your hosted zone where your DNS resolution is, right? So your on-prem client, right, will go to the on-prem DNS. The DNS will have a forward rule that will forward it into the inbound endpoint, and then it gets resolved in your hosted zone, and then that's how clients get the IP address on premise.
Yeah. Pretty straightforward. If folks don't know about inbound resolver endpoints, highly recommend you have a look at it. But there's also an additional feature that we've launched at reInvent, which is called Global Resolver, which allows you not to have to manage those inbound endpoints. So you could just define a global resolver. You can associate private hosted zones to it. And then everyone on-prem who has access to the IP addresses of the global resolver, which are anycast, by the way, so very important, can resolve DNS names altogether, without them having to have reachability to a VPC endpoint in a certain VPC in a certain region and so on. So pretty cool feature. If you've missed it at reInvent, if you've missed our reInvent recap, also have a look at it. And it's very helpful to simplify DNS management in a global environment.
Yeah. The other thing is that you can use custom names, custom DNS names, right? So you don't have to use the long VPC endpoint DNS name. So
for sure,
that's another thing.
There's a question here from Kareem. How do you see customers moving from permit any to locking it down on a per service basis with auth policies? It is worth a dedicated session, I would say, this one, because we are, like, I'm talking to customers almost every day around how to sort of reason about their network security strategy and how to lock down access to certain services and resources and implement this kind of zero trust thing that is now the prevalent way of securing network access. And I would say not easy, not easy. It's such a big, I would say it's a perception barrier first and foremost, because it actually relates to the question that was asked earlier around can't you just have a layer 3 ingress, or like why do you need to just specifically identify every single thing that you want to expose? It's the same thing with policies, with authentication authorization policies, where you have to know what you want your connectivity graph to be. You have to know from somewhere that A needs to talk to B and C needs to talk to D, right? The policy enforcement engine is not necessarily that important. You could do this with Lattice auth policy, you could do this with firewall rules, you could do this with security groups. The implementation part is not the challenging one. The challenging part is knowing A needs to talk to B and C needs to talk to D. So that intent part. And that is a pretty good conversation topic. We have customers who have, for example, created an in place, like in production, what they have currently, dependency mappings around, by looking at flow logs, access logs, and so on, creating these graphs that show A talks to B and C talks to D and so on. And there's a security conversation around, should A talk to B? Should these nodes be connected by a line in the graph or not? It takes time. It's not easy, but it is something that you do need to do if you want to have that granular control. This is what it means, granular control, right? The policy engine is there. You have the controls to implement it, but you need to know what you want to implement.
Yeah. I think the other thing that we usually see or say is on the service network, you keep it like quite broad, right? And then you allow your service owners to define a more granular, or who can access their services.
Cool stuff.
Okay, so while we're on the security topic,
perfect slide. Look at this. The actual slide that answers the question before even the question is asked. Do you see customers insert inspection layer into Lattice? 100%.
Yeah. So we get that question a lot, right? So how do we insert inspection if I want to insert inspection? So we think you could do it with auth policy, right? But if you still want to insert a firewall, how would you do it? So there is something called service insertion in Cloud WAN, right? So when you define service insertion, so earlier we were sharing the routes between what you see on top, like it says like routing policy, you see hybrid and inbound. Before it said share, now it says send via inspection NFG. What does it mean? What does that mean? It means that traffic going between the hybrid segment, which is your on-prem connectivity, to your inbound segment, which is where your endpoint lives, that will be sent via the firewall, right? So essentially, traffic will end up going to the firewall as it comes in, go to your NFG, then go to your endpoint, go to your workloads, either of them, right? And then return traffic will again flow through the firewall and back to your on-premises, right? So that's for inbound. Similarly, for outbound, go ahead.
I like Karen's comment here. Maybe Cloud WAN service insertion to Lattice BFR. I'm highlighting this on the screen, and I'm going to take the link to the recording and send it to our friends on the Cloud WAN and VPC Lattice service teams so that they can take your feedback directly. I would also say that we only have 5 more minutes left, so. From the outbound routing path perspective, maybe I'll let you finish with that, and then final questions.
So I can do it very quick. So network firewall supports multi-VPC endpoints, so you can use the same one and deploy another endpoint in your egress VPC in a way. You centralize outbound NAT VPC, and then you can send the traffic through there when it gets there before it hits your NAT gateway. So you got the visibility of which workload is going out, and then you can filter it like that. There we go.
Cool stuff.
Hey,
we're right on time.
If we want to just jump back to the last slide, any last words on operationally managing all of the bumps in the wire that you've configured here? It's not an easy question.
Yeah.
We probably need a dedicated session on operational management of this kind of architecture. But
yeah, I would say there's one thing here that's important. Think of the fact that this architecture is kind of you said it once and then you kind of forget about it. You should absolutely have everything as infrastructure as code. The only moving parts on like a day 2 kind of operations thing is defining new services and associating them with the service network. That's essentially everything you need to do. Your firewall rules being updated, of course, that's part of the operational day-to-day piece. But other than that, the Cloud WAN segments, the deployment in each VPC, the centralized, the ingress VPCs, they won't change, right? So it's a list at the beginning. You deploy the architecture, and then the ongoing management part. It's a much lighter interaction with the whole environment.
Yeah, I think that resonates in that. It looks like a complicated diagram, but actually once this thing is configured, it's quite static. There's not a lot of movement on routing and changes. Mehdi, you were going to say something.
No, I was just going to say, maybe it looks complicated because we've been trying to putting it all together, you know, in one picture. So we're not just talking, oh, that's how you use Lattice and that's how you use Cloud WAN, and that's how we literally tried to make it realistic and how our customers see it. You know, how can I put all the pieces together? And that's what we're trying to give you here.
Yeah, that makes sense. Very cool.
So I guess as a summary, so we've been trying to address the challenge of running out of private IPv4, just to remind you. I think we haven't mentioned that in a while. We assigned this routable range within AWS, if you remember, in the early slides, that allows you to deploy more VPCs because you're not limited by the number of IPv4. Reduced the number of NAT gateways and reduced costs. So in terms of connectivity, we centralized NAT and we used Lattice as an optimal way to get into your services from on-prem. So we said you could use private link, and we see a lot of customers use private link, but Lattice gives you that extra simplification and flexibility.
Yeah.
And with that, we're right on time. This has been a great session. I learned a bunch.
Perfect.
I love the diagrams too. And again, I'd recommend anyone go back and check out the recording if they want to take some screenshots, or the link to the slides are in there. Thanks, Alex. Thanks, Maddie.
Thank
we'll
you.
see you folks
Thank
next week.
Thanks for hosting us.
Of course. Next week, we actually have upcoming Feb 11, Secure Global DNS Resolution, introducing Global Route 53 Global Resolver. So that should be an exciting session. Yeah, very cool.
Thank you. Thank you.
Love the comment.
Thank you.
Yeah, very cool. Well, thank you.
Thank you. See you next week.
All right. Bye all.